This is question number 10 of quiz 6 for chapter 5. This is actually my second time I'm making this video. The reason I'm doing it the second time is because somehow the first video wasn't made successfully. But aside from the frustration, but I think the upside of that is I have already drawn some chart and also put the numbers into the Excel sheet, so that can help me to save some time. All right, so let me still start by reading the setup. Roger Sterling has decided to buy an ad agency and is going to finance the purchase with seller financing, which means that's a loan from the current owners of the agency. The loan will be for 2 million, financed at an APR of 7% compounded monthly. So what I like to do is to put all this information to a Excel sheet. So the present value is the present value of the loan, 2 million, and APR is 7%. I can change the format to make it to be in percentage format. And the compounding periods here is the number of compounding periods within a year. Since it's a monthly compounding, so this is 12. And MPER is the number of years for the loan. And we also have sort of a balloon payment, which is $500,000, as we will find out. So the loan will be paid off over 5 years with end of the month. End of the month here means immediately, means that this is first, this is annuity, and second, this is an ordinary annuity, along with the $500,000 balloon payment at the end of the year 5. So basically, it's asking how much will the monthly payments be. So to help us organize the thinking or the setup, I have drawn this chart. You can see this is what we currently stand, 0. So we have some cash inflow, which is the money we borrowed, $2 million. And after that, every month, we're going to pay make some payment. So you can see all these should be cash outflow, and they are of equal amount. And that's what this dots here stand for. And that will continue for 5 years. So that already tells us we're going to work with the monthly number, which means we're going to work with 12 times 5, which is 60 months, right? And then the twist for this problem is that in addition to the annuity, we also have this balloon payment by the end of the loan period of $500,000, but this is still a one lump sum payment. So, and the question part A is how much of the loan will be paid off by the final $500,000. So we might be wondering what this is actually asking. Is it asking the actual amount paid by this loan? That I think that's a moot question, right? Because if the setup is asking us that, then immediately this is already $500,000. So why should we need to calculate? So, and with that realization, and also with the realization that we are borrowing the loan at current moment, the $2 million is the money we borrowed now. So when we speak of the loan to be paid off by this balloon payment, we should probably also look at the equivalent value of this balloon payment at the current moment. We know that's called present value, right? That's why I wrote here PV of $500,000. So the question part A is actually asking us what is the present value of this $500,000. And another twist here is that even though this is one single cash flow, but we still need to work with the monthly interest rate. But the interest rate, which is directly given here, APR, is the annual interest rate. So we need to get the monthly interest rate first before we can do the calculation. So that's what I wrote here. The PV of $500,000, we can use the PV function, and then we can and then we can just look at the input. First one is rate. This refers to the, again, here they should be referring to the monthly interest rate. So we should use the APR and divide that by the number of compounding periods within a year. And then the second argument here should be referring to the number of compounding periods. Since we are working with the monthly interest rate, so we should also be working with the number of months. So immediately that should give us this NPER 5 years and then multiply by the number of compounding periods within a year. So that gives us 60. We can directly input 60, but here I choose to input a function to be more flexible. And then the payment here refers to the annuity payment, but we don't have an annuity here, right? Because we are dealing with the balloon payment, which is the one single lump sum cash flow. So that's 0. And the future value here should be referring to the lump sum payment of this balloon payment. But the rule of the Excel function is that if you are inputting this as a positive value, then we're going to get a negative value for the present value. But since I want a positive present value, so I just add a negative sign in front of this in order to get a positive present value. So now I can copy the number back to my lab. And then I have to check whether I followed the rounding requirement. I think I did, because it's asking for the round to the nearest cent, and that's what I did here. So just copy the number back, and then get rid of the dollar sign. And then part B, how much of the loan must be paid off by the equal monthly payments? So once we understand this chart, we know that the loan will be paid off by two streams of cash flow. One is this lump sum final balloon payment, and we have already calculated its present value. Another one is simply by this annuity monthly payments, right? So once we know how much loan will be paid off by this balloon payment, and then the amount of the amount that will be paid off by this annuity will be simply be the difference between this the total loan amount 2 million and this present value of this $500,000. So that's the way we can get the answer. And then that equals 2 million and minus this present value of this $500,000 balloon payment, and copy this number back. And I think I also followed the rounding requirement, and get rid of the dollar sign. And finally, how much will the monthly payments be? Now we know the present value of this annuity, right? And then the final part of this question is asking us what is the payment, right? What is the monthly payment? So we can use the PMT function, and the rate here should also be referring to the monthly interest rate. So it's APR divided by the 12, and then the NPER should also be the number of years, and then multiplied by the number of compounding periods within a year, which means it's the number of months. And present value should be referring to this amount we just calculated. Again, because I want to get a positive payment, so I just added a negative sign in front of this present value. And then I think we should be done, because the other inputs are just by their default. Future values, there's no future value, and type, because this is the end of the year for convention. We are dealing with an ordinary annuity, so that's also the default value for the type. We don't have to worry about that either. So we can just close this function now. And again, I think I followed the rounding requirement to round to the nearest cent. So I just can copy this number back to get the loan payment, the monthly payments. So now I can check my answer. Okay, it's correct.